Hello everyone. I wanted to go over some notes from day 7. Sorry, this is a little bit late. And just wanted to highlight a few things before you take your quiz. All right. And so we went over these notes on Thursday. This is a big part of triangle proofs um, called CPCTC. As it says here, right? Corresponding parts of congruent triangles are congruent. All right, that's what CPCTC stands for. Right? And so what that means is if you and you know that only comes after you prove triangles to be congruent. Okay? And so let's say you prove two triangles to be congruent by SAS. Okay? Well, if you already know that the two triangles are congruent, that means all of the other corresponding parts have to be congruent as well, right? Like in SAS, if you prove that two sides are congruent, then that must mean the third side must be congruent, right? As well as the other two angles, okay? So that's what CPCTC is, right? Corresponding parts of congruent triangles is are congruent, okay? If you want to use the letters CPCTC, that's fine. I can't remember, I think in the filled out reason for proof sheet, um, there's all of this right here where I'm highlighting. Hopefully you can see that, okay? But if you want to write CPCTC, that's okay. And again, that comes only after you prove triangles to be congruent, okay? So in this example here, you were given this figure and these two triangles here, triangle CAM and BAM are congruent by angle side angle. Okay, or don't forget reflexive property. And here's a visualization, right? If they're congruent, then by CPCTC, that means AC is congruent to AB, CM is congruent to BM, and angle C is congruent to angle B because you already proved the triangles to be congruent. Same thing here. These two triangles are congruent by AAS. Okay. And so because of that, right, everything else follows suit, right? PQ is congruent to ST or TS, QR and SR, and angle P and angle T, because if the triangles are congruent, then again the corresponding parts are congruent as well. Okay. Here's a proof. All right. You're given a few things perpendicular, right? BD is perpendicular to AB, and so therefore, and also BD is perpendicular to DE, so therefore angles B and D are right angles. Okay. Angle B is congruent to angle D because if they're right angles, then they are congruent. You're given that BC is congruent to CD, and angle ACB is congruent to angle DCE because they are vertical angles. Okay. Don't forget to use 3 letters instead of just saying angle C. And by angle side angle, these two triangles are congruent. And because these two triangles are congruent, now you can say and prove that angle A is congruent to angle E, okay, by CPCTC. All right. So then we move on to isosceles triangles, and the properties and the theorems you're going to learn about isosceles triangles actually carry through with you to Algebra 2 and also in trig. All right. But the isosceles triangle theorem, right? Remember, isosceles means two of the legs or two of the sides are congruent. All right, that's what isosceles means. But the theorem says if the two sides are congruent, then the base angles are congruent. Okay, and so here where I'm highlighting in red, I think this is on your proof sheet as well. This is a reason that you can put, right? This means if the sides are congruent, then the base angles are congruent. And so we kind of abbreviated it with these pictures here, all right? And the converse is true as well, right? If the angles are congruent, then that means the legs and the sides are congruent as well, okay? And here's the notation for that, right here in red, okay? And hopefully this was self-explanatory as well. If a line or line segment cuts or bisects the vertex angle in half, right, then the line is also a perpendicular bisector of the base, right? So it creates 90 degrees, okay, and it also cuts the base in half with the segment. All right, a couple corollaries, right? We know a equilateral triangle means all the sides are the same, right? All the legs are congruent, okay? So that also means that the triangle is equiangular, meaning the angles are also going to be congruent and the same. Now, for a triangle, if you forget, the degrees of a triangle, no matter what, always add up to 180, okay? So in an equilateral triangle, then each angle is going to be 60 degrees, right? 180 divided by 3, okay? And vice versa. If a triangle is equiangular, then the triangle is equilateral. And here's a proof to go through real quick. You are asked to prove that angle ABD is congruent to angle CBD, right? And most likely I'm going to use CPCTC, right? Because you're not being asked to prove that the triangles are congruent. You're being asked to prove corresponding parts, okay? So you have to prove the triangles are congruent first, and then use CPCTC, okay? Here you can tell in line 2, AB is congruent to BC because you were given in the first statement that triangle ABC is isosceles. So if you have an isosceles triangle, then you have two congruent sides, okay? And when I'm looking at this proof, I feel like statement 5 should come right after statement 2, because if it's an isosceles triangle, right, if those two sides are congruent, then the base angles are congruent, but it's here, so it's fine, okay? D is the midpoint, so that means AD is congruent to CD. And now you can say by SAS, the two triangles are congruent, and so therefore all the corresponding parts are congruent. So now we can prove that ABD and CBD, these two angles, are congruent by CPCTC. And then we also looked at the perpendicular bisector theorem, right? And hopefully this was self-explanatory as well, right? If a point is on the perpendicular bisector, then it is equidistant or the same measure from the endpoints of a segment. So point I, right, is on the perpendicular bisector, and so therefore this distance of 3x plus 2 has to equal 4x minus 3, which is the setup right here. And so therefore x is equal to 5. Okay. And kind of conversely, we have the angle bisector theorem. If a point is on the bisector of an angle, then the point is equidistant from the sides of an angle, right? And so here, S is on the bisector, and so it is equidistant from the sides, okay? So that's why we can say that 6y is equal to 8y minus 7, all right? And so we have y equals 3.5, all right? So I know that was kind of brief, but hopefully that was helpful to kind of hear some of the highlighted sections of these notes, right? And you can listen to that before you take the quiz on these sections.